Let us start with the fresh unit of the 11th class, that is 6th unit, Chemical Thermodynamics. Now, what is chemical thermodynamics? It is the branch of chemistry which deals with the study of the quantitative relationship between heat and other forms of energy. So, first definition we are taking chemical thermodynamics. It deals with quantitative relationship between heat and other forms of energies. So this is called as chemical thermodynamics. Then we have the next definition, that is chemical energetics. So chemical energetics, it is the branch of chemistry which deals with the study of energy changes accompanying different physical or chemical process. So it involves study of energy changes accompanying different physical and chemical processes. So these are the two definitions. First is thermodynamics, where heat is changed into energy, energy is changed into heat, and they are used in the doing work by the different kinds of systems. Then we have the chemical energetics. It involves the measurement of the heat change which are accompanying different physical or chemical processes. For example, we take the example 1 mole of solid carbon is oxidized with oxygen to produce CO2 gas. Delta H here is minus 393.5 kilojoule per mole. So this enthalpy change, it has been studied. This all comes under the chemical energetics. Now, what are the important laws of nature which govern thermochemical changes? Important laws of nature. There are two important laws of nature. Number one is every system in the universe tends to acquire state of minimum energy. It does not want to remain in the state of maximum energy. A hot tea, when kept in an atmosphere, it cools down, releasing the extra energy to the atmosphere. Similarly, hot water is cooled down. If our body gets heated up, we will try to reduce the temperature of the body. So it is the natural tendency on the part of every system to acquire the state of minimum energy, and in order to achieve that the different stages they are obtained by a system. It may obtain the low energy state by changing its state or by losing energy. So this is first law of nature. Second law is every system tends to acquire the state of maximum randomness. Freedom. these two flow, when a system tends to acquire the state of freedom, its energy automatically increases. So this law is just opposite to the first law, and both of these factors, they operate in the same system. The resultant of these two factors that determine the spontaneity of the reaction, that is called a driving force of that process. So this is regarding the laws of nature. Then we come to the important definitions. We have universe. The whole of the mass and energy which constitutes our sun, stars and planets is called as universe. And universe is equal to system plus surrounding. So universe is made of two parts. First part is system. The part of universe which is under study. Suppose this is our classroom. We are studying here. I am teaching. You are getting knowledge from me. So this is our system. The remaining part of this building and the surrounding and the remaining other things which are in the surrounding of this building, they are dealt under surrounding. So system plus surrounding makes the universe. Then we have system. The part of universe which is under study is called as system. Then we have surrounding. The remaining part of universe minus system, we get surrounding. Now system, it is of three types. There are two methods of classifying system. According to first system, it is of three types: open system, closed system and isolated system. As the name indicates, open system is that system which can exchange energy as well as matter with the surrounding. The closed system is that system which can exchange energy but not matter with the surrounding. And isolated system is that system which can neither exchange energy nor matter with the surrounding. Open system, then tea kept in a cup which is uncovered from upper side, it will go on losing energy as well as vapors or water from the tea. Second is closed system. If tea is covered by that your a plate, then there is no loss of matter as well as energy, but energy is lost from the system. And then we have isolated system. If this cup of tea is kept in a thermos flask, then it is neither able to exchange energy nor it is able to exchange the matter with the surrounding. So this system will be called as the isolated system. Then we have other method of classifying system, that is depending upon the composition of the system. It is further of two types: homogeneous and heterogeneous system. We have studied it in the solution also. Solution is a homogeneous system where the composition of the solute, that is same throughout the solvent. That solution is called as homogeneous solution or homogeneous system. Then we have heterogeneous system, when the composition of the solute that is not same throughout the medium, that is called as heterogeneous system. So we have two types of system: homogeneous and heterogeneous system. What is homogeneous and what is heterogeneous system? So we are taking the second way of classifying system. Number one is homogeneous system. This is the system of uniform composition. Then we have heterogeneous system, system of non-uniform composition. So these are the two systems. Systems are classified by this method also. Homogeneous is having the same composition of the components of one substance in the component of other substance. Heterogeneous do not have. So if the sugar is completely dissolved in water, it gives us homogeneous system. If it is partially dissolved, then it is called as heterogeneous system. Then we have the next definition. They are the macroscopic properties of the system. Macroscopic properties of the system are those properties which arise due to collective behavior of large number of chemical species. They may be atom, they may be ion, they may be molecules. For example, water in a sea, it is a macroscopic system and it arises, it assumes a big shape from large number of water molecules, ions, or you can say the salts. So it is a big system, it is a macroscopic system. If the same sea water it is kept in a bucket, then it is a microscopic system, or it is a small system. You are not afraid of by bucket of water, but you are afraid of the sea water in a sea. You are afraid of that. That is macroscopic system. And water in a bowl or in a small plate, that is microscopic system. Then we have macroscopic properties. They are of two types. Number one is intensive properties. Intensive macroscopic properties are those properties which do not depend upon the quantity of matter contained in the system. So these are the properties, they are independent. The IN is here, you learn it, independent of the quantity of matter. Whatever might be the quantity, they do not depend upon that. So pressure, temperature, they are intensive properties since they do not depend upon the quantity of matter, viscosity, surface tension. The thickness of the liquid does not depend upon the quantity of matter contained in it. So we can say the viscosity, surface tension, vapor pressure, refractive index. These are all the intensive properties. Then we have extensive properties. These are the properties of macroscopic system which depend upon the quantity of matter contained in the system. They are called as surface energy, enthalpy, mass. These are the extensive properties, free energy, entropy, and heat capacity. All of them they are called as extensive properties. They all depend upon the quantity of matter contained in the system. Then we have the state of system. This is our sixth definition, state of system. It is the condition of existence of a system. Under those conditions, the system has the constant value of its macroscopic properties. It is said to be the state of system. For example, water has three states, and in all these three states, the macroscopic properties they are different. In the solid state, the temperature of the water is 273 Kelvin. In the liquid state, it is in between 0 degree centigrade to 273 Kelvin. And when it changes into steam, then its temperature is more than 273 Kelvin. So all of these three states, they can be obtained by varying one factor, that is temperature. When it is changed, the state of the water, it changes from solid to liquid, liquid to gas. Then what are state variables? We have the next definition. What are state variables? as the name itself gives us the idea. These are the parameters which are responsible for changing the state of the system. ऐसे parameter which are responsible to change the state of the system, they are pressure, free energy, enthalpy, that is H, we have temperature, internal energy and entropy. Internal energy and entropy. All of these parameters, they are responsible for changing the state of the system. Then we have thermodynamic processes. These are the series of operations which are brought to change the state of system. So the operations which are done under different conditions to change the state of system, these series of operations, they are called as thermodynamic processes. Since in these processes one condition has to be changed, other conditions are to be kept constant. So these changes, they are called as thermodynamic changes or thermodynamic processes. They are of following types. Number one, it is isothermal process. Isothermal process is that process which is carried out at constant temperature. There is no change in temperature, so they are done at constant temperature. Then we have isobaric processes. CHO है ये. Isobaric processes, they are done at constant volume. There is no change of volume during operation of the system, during change of state of the system. Under these conditions, then we have adiabatic processes. When there is no heat change, delta Q is 0. There is no heat change in changing the state of the system. That is adiabatic. There is no heat exchange between system and surrounding during bringing of these changes. Then we have isobaric processes. These are the processes which are done at constant pressure. So pressure is not changed during these operations. Then we have cyclic processes. A changes to D through one step or returns by 3 steps. A, B changes to C changes to B changes back to A. So this is your cyclic process. When a system returns to its original state after series of operations, after obtaining series of stages, it comes back to original state. That is called as cyclic process. Then we have reversible processes. Reversible processes are those processes which can proceed in two directions, in the forward direction as well as in the backward direction. And in these processes, there remains a state of equilibrium between system and surrounding. There remains infinitesimally a equilibrium state between the system and the surrounding. So they are called as reversible processes. They can be reverted at any state of the time. किसी भी state पे उसको reverse किया जा सकता है. Such processes, they are called as reversible processes. Then we have irreversible processes which proceed only in one direction and cannot be reverted at any state, and there is no equilibrium existing between system and surrounding. They are called as irreversible processes. These are those processes which proceed only in one direction. they cannot be reverted back, and there is no state of equilibrium at any point between system and surrounding, and they cannot be reverted by any means. Now, what are the differences between reversible and irreversible processes? First of all, will we have definition of both. Reversible processes, they keep a state of equilibrium between system and surrounding, and the driving force in reversible process is slightly greater than the opposing force. In this case, there is no equilibrium between system and surrounding, they proceed only in one direction, and driving force in this case is much higher than the opposing force. Work obtained from reversible process is maximum because there is no energy loss take place during this process, because they are brought in a very slow manner, infinite simply, slowly they are brought. But in this case, the process is brought immediately, so heat loss is maximum, and work obtained from irreversible process, that is less than maximum. It is more theoretical. Reversible processes cannot be achieved perfectly in the actual conditions, so it is very much theoretical, while irreversible processes, they are the natural processes. So driving force we have already discussed, that is very slightly greater than opposing force. In this case, driving force is much greater than the opposing force. Then we have the heat. Next definition, that will be air definition. What is heat? It is the mode of exchange of energy between system and surrounding. If system is at high temperature, it will definitely transfer heat, it will definitely transfer energy to the surrounding and vice versa. So heat, it is a mode of energy exchange between system and surrounding due to difference in temperature. Then we have the work. It is of many types. Work is said to be done when the point of application moves in the direction of applied force. So W is equal to F into X. That is the force carried out to change the state of the system through a distance X. Now A is lying here. We gave some force to it. A comes here. This is its initial state. This is final state. So work is equal to force applied into delta X, X2 minus X1. The change of the distance, this is called as work. Then we have the types of work. For gases, it is work of expansion. If a gas is contained in a frictionless piston fitted to a cylinder, and then some energy is given to the gas, then gas will absorb that energy and it will try to expand, and this is called as work of expansion. This is work of expansion. It is given by minus P delta V, that is change in volume. Delta V, you know, it is V2 minus V1, and P is the external pressure against which gas tends to expand. This is the piston. Here the external pressure is applied against which gas is expanding. So this is P, and this is your volume, initial volume V1. If it expands, then volume will become V2, V2 minus V1, that will give you delta V. It is given minus sign because during expansion gas has to work, therefore it is given minus sign. Then we have work of contraction. If piston is applied more force, then it will be coming in the lower direction. Now V2 will be less than that. So here delta P delta V is taken as positive because energy is absorbed by the system, which is supplied from outside to compress it. That is absorbed by the system. Then we have third type of work, that is called as electrical work. This is given by electrical work. It is given by NFE naught cell. N is the number of moles of electron which are flowing from one terminus to another terminus. F is the Faraday, it is the charge carried by 1 mole of electrons, and E naught, it is the voltage difference between two terminals of the cell. So it is E naught cathode minus E naught anode. Now what are the units of work? It has the unit calorie of heat and work. 1 calorie is equal to 4.184 joules. So they are measured in calories or in joules. 1 kilocalorie will be equal to kilojoules. So it is changed into kilocalories. Then this value will change into kilojoules. So 1 kilocalorie will be equal to 4.184 kilojoules. 1 joule is equal to 7 hours. So these are the interrelations between them, 10 raised to power 7 hours. Now, what is the difference between heat and work? We can say work is a organized form of energy while heat is a unorganized form of energy. Work can be used to change the state of the system. Heat, it is not completely used. It's some of the heat that is lost during the process. So heat is a unorganized form of energy while work is said to be an organized form of energy. Both of them, they become equal when the process is carried out at constant volume. Since we know Q is equal to P delta V, so then that is equal to W. So when delta V is 0, then Q and W, they will be also equal. So this is all about our first lecture. Next time we will be starting with the laws of thermodynamics that will cover in the second lecture. Thank you very much.